The purpose of this video is to briefly explain DDE, Dynamic Data Exchange, and how it can be used in conjunction with Parker Compumotor's 6000 series motion control products.
A dynamic data exchange, otherwise known as DDE, is a software protocol that allows information or data to be exchanged between two Windows applications. Since a DDE server is a software protocol, it must be loaded into your PC or computer along with the Windows applications you intend to use. Parker Compumotor has developed its own DDE servers to be used in conjunction with the 6000 series motion controllers. The DDE server will allow information or data to be exchanged between 6000 series motion controller and many Windows applications. In particular, today we'll show you an application in which the Compumotor 6200 series motion controller or two-axis stepper indexer will exchange information between itself and a Microsoft Windows application, Excel. This will call upon the DDE 6200 server. Currently, there are three Compumotor DDE servers available. First, the DDE 6200, designed for the two-axis stepper indexer, which we'll use on our demonstration. Secondly, the DDE 6250, designed for use on the two-axis servo controller. And lastly, the DDE AT 6400, designed to be used for the four-axis bus-based stepper indexer. As new 6000 series motion controllers are released, their DDE servers will also become available.
Now that we have a basic understanding of the DDE server and how it works, our demonstration will be broken down into four components. First, an explanation of the equipment we have used. Second, a completed operator panel and the capabilities of dynamic data exchange. Third, the steps we took to create this panel and communicate through DDE. And lastly, we will review the steps taken in using DDE with Compumotor products. Our demonstration setup includes a personal computer with the DDE server installed on the hard drive. We have also configured the system so that DDE directory is in the path. More information about installation and correct system configuration can be found on the readme.txt file of the DDE server disk. We also assume prior knowledge of a DDE-compatible Windows application, which might include Intellusion's DMAX, Wonderware's InTouch, and Microsoft's Excel. Our operator panel uses Excel, which will incorporate specific Excel commands. We're also using a Compumotor 6200 and two stepper motors and drives. For correct connection between the 6200 and the drives, please refer to your 6000 series user guide.
Now that our setup's complete, we'll show you the results of the steps we're about to take and the capabilities of the dynamic data exchange. Here we have an Excel spreadsheet displaying information being read from the 6200 motion controller. As we can see on the screen, we have motor position and steps, motor velocity and revolutions per second for both axis 1 and axis 2. We also have displayed the first 6 inputs of the 24 of the 6200 motion controller and the first 6 outputs. In addition to this, we displayed a graph of the motor velocity and the motor position through an Excel graphing function. We've also created buttons, which is another Excel feature drawing upon its Visual Basic capabilities. With these buttons, I can initiate macros and send immediate 6000 series commands or program names to be run on the 6200 motion controller via the DDE server. For instance, I have an output toggle button, which sends a macro to toggle the outputs, which we could see on the output display. As we toggle it, it turns it on, toggle off, back off. Now we can also use a start motion to initiate a continuous motion on both axis 1 and axis 2, which we'll see in the motor position and motor velocity, and will also be reflected on the buck graphs. We'll start motion. Watch the motor steps going, and the motor velocity is in full 5 revolutions per second on axis 1 and 15 revolutions per second on axis 2. We've exceeded our graph, so I'll zero the position to start it over, and we'll see the motor position start over at 0. Now we'll stop motion, which will send another immediate command to the 6200 to stop motion. As we see, the motor velocity has now stopped and the position is held constant. We'll now zero this out for another move. Okay, now we're going to perform a move sequence, which will initiate a pre-programmed sequence within the 6200. As we toggle it, we can see the move being performed. We can see the motor position and motor velocity are both being updated. The graphs are being displayed. And we can also see now on the 6200 motion controller the axes actually moving. Now we'll stop motion, which will again stop it, and we'll perform the continuous move. Zero position to reset to 0, and once again stop. Other capabilities, we have the input shown here. If we toggle a switch, as I toggle the inputs on and off, you can see it being displayed on the panel here. I'll set 1, 2, and 3 all to 1, and we can see that being reflected on the inputs. Now 4, 5, and 6. We can see they have also changed. Again, I could toggle the outputs, and I'll start motion. We could also do different moves. We could still toggle the inputs while the motion is moving, and it will still be updated. Stop motion, and zero the position. Everything shown here for the 6200 can also be applied to the other 6000 series motion controllers as well. In addition, the features shown here are very specific to Excel. However, the information our data passed is specific to the 6000 series DDE server and can be accessed by any Microsoft Windows application that supports DDE protocol. Therefore, the different applications all have access to the same data to and from the DDE server and differ only by how they use and process this data. We begin building our test panel step by step by first opening File Manager and locating the DDE server. As you can see, the readme.txt is also located here. We initiate our DDE server, close our File Manager, and you can see an icon. The DDE server will appear on the screen. We'll open this up, and we'll check if the transfer has been connected. We see a check mark, which means it has. If it hasn't been, which is shown by a non-check mark, when we close this, the icon will appear with an X through it, which means it's not connected. We need this to be connected, but first we can check our settings by clicking on the serial port and noting COM1. This is the setup we want, so we'll check OK. connect, and minimize. No X, we're connected. Next, we'll initiate Microsoft Excel. Begin to build our panel in an Excel worksheet by entering text into cells to create our labels. As you can see, we've skipped over many repetitive steps in order to save time. We're now ready to create our buttons. We'll do this by choosing the button icon from the utility bar, dragging the cursor into the display, and creating the button. We're not yet ready to assign this button to a macro, so we'll cancel out of here and rename the button to Start Motion. We'll repeat this process for all of our buttons. Our buttons are now complete, and we're ready to start creating the graphs. We'll create the motor velocity graph now by selecting the motor velocity label along with the cells that will contain the data. Now we can select the graph toolbar and drag it into the screen. The labels, buttons, and graphs are now completed. If you need further assistance on these Excel functions, please refer to your Excel User's Guide. Now we are ready to start requesting data from the DDE server. This is accomplished by selecting the cell in which data is to be displayed and entering the appropriate Excel formatted statement. We will choose the motor position on axis 1. As you can see, the current position is now entered and displayed. The DDE server can only access a limited set of data from the 6000 series motion controller. This data is available in the fast status area of the AT6400 or as equivalent information in the 6200 or 6250. This information will be continuously and automatically updated by the DDE server at a rate of up to 55 milliseconds, which is the current resolution of the Windows timer. MP1 is the actual command sent to the DDE to request motor position. The readme.txt file on the disk provided will have a list of available DDE status commands to request data from the 6000 series motion controllers. Actual list of all the possible DDE request commands. At the top, we have a motor position, which we are using currently, the MP command. We can also request encoder positions using the EP or motor velocities using MV. We'll also be using the input request command and the output request, the IN and OUT. There are many other request commands listed here. All these commands are meant to request information from the 6200. However, the CMD allows us to send character strings to the 6200. We will use this in our macros to send 6200 commands down to the indexer. We've now completed the remaining display cells using MV, IN, OUT, DDE request commands, and all the information is now displayed on our panel. We now must create the necessary macros and assign them to our buttons. We begin this by opening a new file and selecting the macro sheet option. We go into Formula and define a name, which we'll name Start Motion. And we want to define this as command. We can now type in the macro definition, and once again, these are Excel-specific macro statements. I'll begin by expanding the column so we can see the full text. I'll start by entering the name of the macro. Now we can begin by entering the rest of the macro. And any questions concerning the Excel macro statements are addressed in the Excel User's Guide. The initiate, poke statements, these are all Excel macro statements. The poke A3 CMD C4 initiates the macro on cell A3 and sends the command contained on C4 to the DDE 6200 server. We'll enter the command here, and we'll use immediate 6000 series commands that should already be familiar to you. We'll send a sequence to initiate a continuous move on the 6200. The colon here is just the limiter, and the bang declares an immediate command. And our acceleration for both axes. Velocity. Finally, our go. Now this macro is complete, and we can start on our next. At this point, I've completed the rest of the macros, and I'm ready to assign them to their corresponding buttons. We do this by selecting a button, choosing the macro, and choosing Assign to Object. This lists all the possible macros that can be assigned to this button. We pick Start Motion and click OK. Now, whenever we select this button, the macro assigned to it is initiated, and it sends down the corresponding 6200 commands to the controller. The move sequence, however, sends down an actual program name instead of an immediate 6200 command. Let's look at the macro. Find the macro, move 1, which is the name of it, and we see that this is not a 6200 command. This is the name of a program. Once this button is selected, the macro runs, and it will initiate the predefined sequence in the 6200 memory that was downloaded earlier, named moved 1. Looking at the other macros, we have 0 position, which sets the position counter to 0, and stop motion, which sends down an S or stop command. We'll go back to display. Now let's select a button. Select the start motion, starts our predefined motion, or rather it starts our continuous move. We stop the motion. We'll zero the position, toggle our outputs, and do a predefined move sequence. As we can see, our panel is now fully operational.
In summary, let's review the steps to using DDE with Parker Compumotor's 6000 series products. First, make sure you have installed the correct DDE server that corresponds to your 6000 series motion controller. Second, review the readme.txt file on the DDE server disk. Third, verify that the DDE server is running and connected properly. Fourth, a DDE-compatible Windows application should be running. And lastly, the appropriate syntax should be used to communicate through DDE. Following these steps will ensure proper operation of your DDE server application. We hope this video has provided some insight into Compumotor's dynamic data exchange servers and their capabilities. If more information is needed, please contact your local Parker Compumotor distributor.